Okay, so here in this video, I'm going to talk about the magnetic motor starter. So the motor starter is used to start and stop motors used in various industrial applications. And so basically what a motor starter is a contactor with overload protection added to it. Okay. So check out my other video on contactors for information about that. So in here I'm just going to focus on the overloads. So these are some of the same contactors that I used in that video example, except here I've added the overload terminal blocks to it for protecting the motor. So this is for overcurrent protection, so that if any or all of the three phases that are connected to the motor draw excessive amounts of current for whatever reason, the overloads trip and de-energize the contactor portion of the motor starter to shut the motor down to protect itself. All right, so I'm going to look at some specifics with the overload block and show you how that works and look inside of it. So for your contactors, you have your three phases that would be coming in the top of each of these, and then the power comes out down at the bottom here when the contacts close, when the coil energizes. Then coming out of that, it's going to go into your overload block. So these three metal pieces here actually plug into the bottom of that contactor, as you can see here, and you just tighten those screws down. So then current can flow through these into the overload block, and then it comes out on this one down here on these three screw connections of the overloads. Okay, so these look different depending on the overloads you have. So here they are down here, 1, 2, and 3 to go out to your motor. Here they actually are magnetic overloads, so there's no screw terminals here. They actually go through this block into the three connections on the contactor itself, and then just the magnetic field that is around the wire is monitored to give us the overload protection for those. Okay, so that's a magnetic overload. These are all thermal. All right, so on this one you have an adjustment to set the current rating. So all of these are rated for different amounts of current. You can get them in whatever size you need them to be for the specific motor that you're using, and this has a range where you can adjust that. Okay, so one thing you have to account for with the motor, of course, is the inrush current that you have when you first start up. So that's why you may need to fine-tune this for the specific motor that you're using. All right, then you have your reset, so that when the overloads trip and you need to reset it, that's the button there. Again, that looks a little different on each one. So that's your reset on this one. That's a bigger reset button on that one. You also usually have a method for testing the overloads. So for this one, it's right here, this little tab on the side. You see it pop out once I reset it. This one is this blue button here. I can test it. You can hear it click. And then for this one, you have down in here, you have to take a little small screwdriver. See, it says trip there, and you put it down in there, and you can trip the overloads for testing them to be sure they're working properly. All right, so in addition to that, you have your overload contacts. Now this is what's part of your control circuit. So here it's 95 and 96 for your normally closed contact, and that's what you would be using as part of your control circuit to protect the motor starter. So in your control circuit, you bring power in to A1, then you would come out of A2 of the coil, which is the neutral side for this, or well, this is the negative side for this DC one, or neutral side if it's a 120 volt coil, and then bring a wire from A2 into 95, and then come out of 96 and go back to your power supply. So it puts that normally closed contact in series with the coil of the motor starter, so that when the overloads trip, that contact at 95 and 96 open, and then it de-energizes the coil of the contactor portion of the motor starter, so all the contacts open and removes all power to the motor itself. All right, so that's the important one, 95, 96. There's 95, 96 on that type. And then on this one, it's right here, 95 and 96, okay? And that's the standard numbers for that, by the way. And then we have a normally open contact for the overload, so that's not always used, but it's available there if you want to use it. It's 97 and 98. So this could be if you wanted to say a pilot light to come on to indicate that an overload has occurred for this motor starter, or if you want it to activate a buzzer or some type of alarm, you can have it do that. So that just gives you some additional control with the overloads. Okay, but 95, 96 is the important one. All right, so I've removed the screws here just so you can see inside of this and see the actual thermal overloads. So remember, this is where current is coming in from the contactor, and then it flows through these thermal overloads. Okay, so you see this wire wrapped around there, current flows through there. So in normal conditions, these will get warm, but they won't be hot. If the current gets too high, then these will get warm and actually trip the mechanism over here to let's see, to trip the overloads. So you can see how that moves there when I'm using the test function. Okay, but that's what actually causes the overloads to trip, is by any of these heating up and moving the contact over here. So this is the contacts for your 95, 96, 97, 98 over on this side of the overload. Okay, so a lot of people get that confused with the overloads. They think that, you know, in the diagram where they see the 3 thermal overloads, that those physically open, but that's not the case. I mean, if in an extreme event that may happen, if it gets too hot, it eventually would burn up if your motor continues to run. But these trigger the 95 and 96 to open, and that causes your contactor to de-energize and shut down. So that's how the overloads actually work. So yeah. Now these all, of course, are designed a little bit differently just based on the size and whether they're, of course, thermal or magnetic overloads that you're using. Okay, so for these overloads, just like with the contactors, you want to make sure that they're going to be able to handle the amount of current that your motor is drawing. So you want to look at the motor nameplate, look at the full load current rating on that, so that you properly size the overloads. So just like any overcurrent protection, just like fuses and circuit breakers, you don't want it to be too high or too low, because if it's too low, they're constantly going to trip and you're never going to be able to run the motor. If you go too high, then the high amount of current can damage the windings of your motor before these ever trip. So you want to get the right size of overload for your particular motor application. Okay. And that's all for the magnetic motor starter.